When people say energy is quantized, what they mean is that it is transferred in certain whole number amounts. There is some number or amount that is the only unit that energy can be transferred at for that particular compound or arrangement of electrons, really. Now, I can't really explain why that is until I know more about electrons, electron orbitals, and bonds. And to be honest, it really doesn't make a whole lot of sense to learn this part of it first until I've learned about that. But I don't have time to reorganize this whole book. So I'm just going to talk about the basic idea of energy quantization because it's relatively simple, even though it sounds really complicated, and they always seem to make it sound more complicated than it really is. So to come up with an explanation for this energy quantization, I've come up with an analogy. And the analogy is currency. So I have a bank or some money or a wallet, whatever. Now here's a question. I guess this is really what this is really the question that spawned this whole deal, was can energy be transferred in any amount? And before I think about that, let me ask about money or currency. Can I transfer currency in any amount? Most people would probably respond yes. But if I were to think about it very carefully, I would discover that in fact that's not true. Take the currency American dollars. The smallest unit is the cent. So in fact, using this example, I'm going to say that money in fact cannot be transferred in any amount. It has to be transferred in quantities of at least 1 cent. So I can have like $100 because that's a multiple of 1 cent. I can have 28 cents, that's a multiple of 1 cent. Something I cannot have is a half a cent or a tenth of a cent. How am I going to transfer someone a tenth of a cent? I can't do it. So that is the idea of the quantization of energy. It's just basically like currency. It's a currency transfer. I can only transfer energy as if it were money. I can only transfer money in the smallest denomination of that currency. In United States dollars, it happens to be 1 cent. I can transfer increments of $100 because that's a multiple of 1 cent. 1,028 cents, that's a multiple of 1 cent. So that's the idea of the quantization of energy. Now, the way to correlate cents to this energy is that HV would be the equivalent of the cents in currency, or the smallest denomination. And that smallest denomination is going to vary depending on what compound it is. Every compound, every set of electrons is going to be different. But for whatever that number is for that compound, that is basically going to be the smallest unit of energy that can be transferred, and it is also the only transferable unit. I can only transfer energy in units of HV, similar to the way that I can only transfer money in units or in multiples of 1 cent. I can transfer 2 cents, I can transfer 3 cents, 4 cents, 5 cents, $1, $5. Can't transfer $5 in a 27th of a cent. That can't happen. And the N is just to say that I can only transfer in whole number amounts. This would be similar to writing N times 1 cent. And this would be change in money. So now that I've written it this way, it should make a lot more sense. H and V are what are going to give me the energy amounts of which I can transfer. H is Planck's constant. It was calculated by, well, never mind about that. It was just, he just found the smallest amount. And it is 6.626 times 10 to the minus 34th joules a second. The second cancels out the frequency which would be cycles per second, so those will cancel out and will leave me with just joules. And then the N is just the amount that gets transferred between. It's like the N 4 cents. So hopefully that does a decent job of explaining what the quantization of energy. And I guess I forgot to just talk about the term quanta. Quanta is just quantity amount. So in this case, the quanta is HV. In the case of currency, the quanta is 1 cent.